Inferring intelligent design from purpose, information, and complexity, beyond reasonable doubt. Summary. No rational person would claim that a computer or an aircraft arose by random chance or natural law even if they had never previously seen a computer or an aircraft before. Even if we have never seen a computer or an aircraft before, we are completely rational to infer that a computer or an aircraft is intelligent designed because we see one or more of the following elements. A. Purposeful arrangement of parts. B. Complex functionally specified information. C. Functional irreducible complexity. The presence of any of the three elements above is proof, beyond a reasonable doubt, of the presence of intelligent design. Introduction. When we encounter a system with certain distinctive features, we are rational to infer that it was the product of intelligent design, even if we have no prior experience with similar systems. Consider, for example, a computer or an aircraft. Even without any prior knowledge of these machines, no rational person would attribute their existence to random chance or natural laws alone. Instead, based on observable features, such as a purposeful arrangement of parts, complex functionally specified information, and functional irreducible complexity, it becomes evident that these systems were intentionally designed. The presence of any one of these elements, let alone all three, provides strong, even conclusive, evidence of an intelligent cause. 1. Purposeful arrangement of parts. One key indicator of intelligent design is a purposeful arrangement of parts. In both natural and human-made systems, when parts are arranged in a way that achieves a specific function, we commonly attribute this to intentional design rather than to random processes or natural laws alone. Consider the example of an aircraft. The wings, fuselage, engines, and cockpit controls are arranged in a specific configuration to enable flight. Each part contributes to this purpose, and if any essential component is missing or incorrectly placed, the aircraft will not function. The specificity and interdependence of each part's role strongly indicate that the arrangement was intentional. In our experience, we consistently find that purposeful arrangements, where each component is uniquely positioned to achieve a specific goal, are produced by intelligence. We don't attribute the intricate layout of an aircraft or computer to natural laws or random forces because these systems reflect intentional planning and functional organization. Similarly, when we observe biological systems with precisely arranged parts that achieve complex, purposeful outcomes, such as photosynthesis or cellular respiration, we are rational to infer that these too are the result of intelligent causation. 2. Complex functionally specified information. Another hallmark of design is the presence of complex, functionally specified information, FSI. This type of information is not only intricate but also directed toward achieving a specific outcome. For instance, computer code contains sequences that direct operations within software, and the code must follow precise rules to function correctly. Similarly, DNA is a biological code, with sequences of nucleotides, A, T, C, G, that carry instructions essential for the development and functioning of organisms. The specificity and functionality of this information go beyond what chance processes can plausibly produce. The complexity here is meaningful and directed. Random sequences of letters or bits may convey no purpose, but functionally specified sequences do. In our experience, only intelligent agents produce information that is both complex and specifically arranged to achieve a function, whether it's the code in software or the genetic instructions in DNA. Such information is structured with purpose and intention, underscoring its intelligent origin. 3. Functional irreducible complexity. Functional irreducible complexity describes systems in which all components must be present simultaneously for the system to function. Remove one part, and the entire system fails. This concept, originally formulated by biochemist Michael Behe, is particularly evident in molecular machines like the bacterial flagellum. The flagellum operates as a rotary motor, allowing bacterial movement, but it requires numerous interdependent protein components to function. If any one of these components is missing, the flagellum loses its ability to operate, rendering it useless. In both biological and artificial systems, irreducible complexity is a strong indicator of design. We understand that intelligent agents build systems with interdependent parts to achieve a complex function. For instance, a car engine is irreducibly complex because it needs all major components, pistons, crankshaft, fuel system, ignition, to run. Like the flagellum, the car engine's parts are arranged in such a way that they cannot be simplified without losing functionality. Random processes cannot produce such intricate, interdependent structures because incomplete forms offer no advantage and, in fact, would be disadvantageous. In biological systems, functional irreducible complexity suggests that natural selection alone cannot explain these structures, as the incomplete intermediate stages would have no survival benefit. Instead, such complexity indicates that an intelligent cause orchestrated the components to work in harmony. 4. Any one of these elements is proof beyond a reasonable doubt. Each of these elements, purposeful arrangement of parts, complex functionally specified information, and functional irreducible complexity, independently points to intelligent design. If we encounter a system exhibiting even one of these features, we are rationally justified in concluding that it was intentionally designed. For example, if a person found a functioning computer with circuit boards, software, and interconnected components, they would be entirely reasonable to infer intelligent design without ever having seen a computer before. The purposeful arrangement of parts, the information-rich code, and the interdependent hardware configuration make a strong, rational case for design. Similarly, encountering biological structures with these same features, e.g., the eye, cellular machinery, supports the inference of intelligent causation in the origin of life. The reason this inference is beyond reasonable doubt lies in our consistent experience with these types of systems. Every complex, specified, and functional system we know is produced by intelligence. Natural laws alone produce order, such as crystallized structures, but not complex, functional systems. Random processes yield randomness but not specified complexity. Therefore, the presence of these elements in any system we encounter provides more than sufficient evidence to conclude that it was designed. 5. Conclusion. Intelligent design is the most rational inference. When we encounter purposeful arrangements, complex functional information, or irreducible complexity, it is rational to conclude that an intelligent agent is responsible, even if we have no prior experience with similar systems. The inference to design is not based on blind faith or analogy alone but on a logical assessment of the evidence and the limits of natural explanations. These three features, purpose, specified information, and irreducible complexity, provide a framework for identifying the hallmark of intelligent design. In our experience, intelligence is the only known cause capable of producing systems with these attributes. As such, recognizing design in a computer, an aircraft, or biological systems is a rational conclusion based on consistent evidence, and it stands beyond reasonable doubt. Thanks for watching. Please like, share and subscribe, and comment below if you agree or would like to add your thoughts. If you would like me to respond to your comment, please make a level 1 comment directly below the video. I will respond to all polite level 1 comments even if it takes me a while, due to other commitments.